All right, so let's get started. So today we're going to be talking about lines. We're actually kind of going backwards because we've done chapter 2, so we're now going back to chapter 1 for a second. So we've already talked about rise and run and how to calculate your slope. So we've done that a lot of times. So right here, I'll do the first one. I wanted to do the second one, and there's a reason I want you to do the second one. So here over rise over run, here we can just count. Here we have 2 points. We can actually use the formula that the function formula, but here we can just count. So 2, 4, 5, and so we go down 1, 2, 3, 4, 5, 6, and over 2. So here I have a slope of -3. Here also we could have chosen this point. So real quick, just to make sure you guys are awake, what's the slope of this line over here? All right, so -1/2, 1, 1, -1/2, -1/2. We gotten a lot of really close answers. Um, so here, let me go for it. So here, if I was doing this, I'd go up, down 1, 2, but notice the spacing here. Notice the spacing here. This is over 1, 2, so it's down 2 over 2, so it's -2 divided by 2, because my rise is down 2 over 2, so this is -1. So be careful. Be careful with, I'm not going to do this ever on an exam or anything, but this is what I call a life lesson. When you see graphs out in the wild, please, 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 very, 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 very careful on what they use to space or how they label them, because they will lie to you. Graphs, graphs like, oh, that's graph, it must be science. No, it's probably propaganda in the form of science. So be careful when you look at graphs. Um, and when you read graphs and do that, so be very precise. And so that's all I have to say about that. So let's go ahead and calculate some slopes real quick. I'm pretty sure you know how to do this, so I'm going to I'll go at a decent a rate that's fair, but I won't go too slowly. So here we're going to so in order to find this, we're just going to use our formula from up here. So rise over run, so y2 minus y1 minus x2 minus x1. It really doesn't matter which one you call y1 or x1 for the lines at all. So I'm going to call this one x1. I'm going to call this, oops, that does not look like a y. y1. I'm going to call this x2 and call this y2. So I'll have 5 minus 0 over -1 minus a -2, which becomes, hold on, I have that in the wrong order. I have -2. What am I doing? Let's start from the top. y2 is 5. y1 is -1. So it'd be minus minus of 1. x2 is -2 minus 0. There we go. I can put stuff in the right order. And so here on top, I'll have 6. Here on the bottom, I have -2. So -2 over 6 simplifies to -3. See if I can do it better this time. So here I have a 4. Here I have a 2. So 4 minus 2. Here I have -2. Here I have 0. So this becomes 2 minus -2, which is -1. Okay. So just be very careful. Like I said, always have your notes in front of you, because sometimes when you're teaching, not paying attention to the actual math you're doing. All right. All right, so I'm going to introduce 3 different equations for lines. Each of them have their own purpose. So the first one is the point slope form. The main purpose of this one is if you're given a slope and a point or 2 points, you can write an equation of lines. That is the purpose of this one. It's just to quickly given information about your line, you can write an equation. So given this, we can just plug this directly into the formula and just crunch out the numbers. And so here I'll have y minus a -1 So it would be y minus 1 equals m, which in this case is 3, x minus x1, oops, which is 3. And then from here, what we almost always do is we almost always solve it to, oops, that'd be minus 1, sorry. We almost always solve it to the other form, which you know, which I'll show you down at the bottom. It is the slope-intercept form. So write all the above, we'll put them all in slope-intercept form. The reason we put it in this form, it's really easy to tell information. We instantly know what the slope is, and we instantly know where the y-intercept is. So we know a point and the slope really fast. And so this is the most convenient way to give someone a line. This is the most convenient way to find the equation of a line. And so we'll go through, and so we'll just do that. So here, let's go ahead and crunch through another one. So here I have y minus 2 equals negative half of x minus 4. We crunch that through, we get y minus 2 equals minus a half plus 2. So x, sorry, I use this y equals negative 1 half x plus 4. All right, so here's what your homework looks like, and this is what will be on the exam. Is find the equation of a line going through the following points. So here, the first thing we want to do is find the slope. So here we'll have 4 minus 2 over 0 minus 1. So 4, 2, 0, 1. Make sure you get these in the right order. It's easy to mess them up. I did. So just double check yourself. So this would be 2 over negative 1, which is minus 2. So now that I have the slope, I can choose either point. Now, which point am I going to choose? I'm going to choose this point. Why? Because this is 0 in it, right? It makes my life easy. So it'd be y minus 4 equals 2x minus 0. So this quickly, I can just solve out to be 2x plus 4. Or negative 2x plus 4. So the nice thing here, so here once again, we'll solve for this. So I'll have 2 minus 1. 2 minus 2 would be plus 2. So here I'll have 1 over 4. That's my slope. I'm going to choose a point. Here I'm going to choose this one just because it divides better. So try to, when you're choosing your point, pick which one makes the most sense. So 1/4 of x minus 2. And then here, I'll have y equals 1/4 x minus, so this would be minus a half, and then plus 2. So this is y equals 1/4 x plus 3 halves. All right. And then the rest of this is just, we did that already. We've already written this all in slope-intercept form. All right, so that, I'd be highly surprised if all of this wasn't review for you guys, like real review. Some of the other stuff might be slightly new, so I won't just like plow through it. So let's start with that. So what about this? So what happens, and so here if we have a horizontal line, the slope is 0. Here if we have a vertical line, the slope is undefined. And so here, let's pretend I was trying to find the slope of this line, right? Well, the slope of this line is 4 minus 2 over 1 minus 1, right? So this gives me 2 over 0, which is undefined, right? Undefined. So if I ask you, what's the equation for this line, what would you tell me? Does anyone know? Let me see if I can gauge if this is a review or not for you guys. No real numbers? No, there is a slope to this. There is a line I can write for this. Yes, so someone got it. It's x equals 1. Notice here that x is always 1, and then it's that. And so if I graph this line, so I was going to graph this line here at x equals 1, it would be, well, if I can hit at 1. And so it's just a straight vertical line. Here we can do the same thing again. Here I'll have 1 minus 1 over 2 minus, so minus 2 gives us 0 over 4, which gives us a slope of 0. But the slope of 0 is perfectly fine. We can plug that into our formula. And this will just give us y equal, or y, so if I actually put y minus 1 times 0 times x minus 0, or doesn't matter, x, we'll just use this one, I guess, minus 2. Well, that just, it's just y minus 1 equals 0, or y equals 1. Notice here, we have the same here, we can skip to this, okay? And so if the 2 points they give you, if the x coordinate is the same, it's just x equals that point, right? If the second two are the same, it's just y equals that point. Okay. You might see that on the exam, just something good to know. Just like, well, what happens when your formula doesn't work? Well, you have solutions. Here's another form of the line. You may not be too familiar with this one. This is called the general form. I know this is standard form. Standard form of the line. This is useful for graphing and finding intercepts. So if you want to find out intercepts, which may be super useful for some things, like pretend this is the line, because if you're in like economics, sometimes you have your capital wage, or you have X amount of money. How much do you invest into the machinery, and how much you invest into personnel, and you make a little graph for it, and you try to figure out where you can maximize your production. It's just one of the things you do, and it's linear, can be linear. Let me phrase that, can be linear. And so this would be the best way to use that. So it does actually have real uses out in society. And so the best way to do this is you just find the intercept. So here, if I set x equal to 0, so x equal to 0 is the y-intercept. Well, what must y be? Well, y must be, in order to make this 0, y must be 4, right? Cheat sheet back up, right? So, because if x is 0, this is minus 2y plus 8 equal to 0. Well, what must y be? Well, y equals 4, right? So here I have the intercept 0, 4. Remember, intercepts are points. If y equals 0, x must be negative 2. And so here I have negative 2, 0. And so that gives me my line. So here I'm at negative 2 and 4, and then I can just draw in my line. All right, so I'm going to explain how to kind of do this in your head. So if this is 0, I want to make this 0. Okay, so if x is 0, so let's just write that down, 0, y must be, in this case, negative 4. And here I'll have you guys give me one. What's the y-intercept, or the x-intercept, right? And that's where y is 0. 6, yeah. So 6 is the y-coordinate. Technically, if I was being pedantic, the intercept is that. It's 6, 0. It's, but you get me what I wanted. So here at negative 4, so here at 0, negative 4, so down to negative 4, then over to 6, which is too off from here. We have this line. Oops. We have a line that I almost missed. And so that's how use standard form to quickly graph lines. It's real quick to graph lines. Maybe not as quick as the slope intercept form, but it's nice to know the intercept straight away. And so that's why we use that equation of a line. We'll talk about parallel and perpendicular. Oh, and then we just used lines to prove something real quick. All right. So let's talk about parallel. So this is the definition from your book, but the definition is not true. So I kept it from the book when I was teaching out of the book, which I still kind of am. So 2 lines are parallel if and only if they have the same slope. That is true. 2 lines are perpendicular if and only the product of the slopes -1. That is not true. And I'll explain why it's not. If and only if, let me just do a quick little math rant. It's important to know if and only if means if this is true, then this was true, and if this was true, this was true, right? So if the products of their slope of two lines, right? If I have 2 lines and the product of slope is -1, that means it's perpendicular. That I'll buy whole cloth. If it's perpendicular, does it mean the product of the two slopes of their slopes is -1? That is actually not necessarily true, because if I take the line x equals 1 and y equals -2, these are definitely perpendicular to each other, right? Because, they're definitely perpendicular. This is definitely right angle, right? But the product of this slope is undefined and 0. That's not -1. so it's perpendicular. So two non-vertical lines. Vertical or horizontal lines are perpendicular. And so you have to make that little caveat. So let's just go through this real quick and do this. This is almost guarantee I'll give you one of these questions on the quiz and probably on the final. Find something that's perpendicular and parallel. It's just, it tests all the concepts at once. All right, so let's look at the slope of this line. So the slope of this line is, let's just use this point and this point. So it's over 1 up 2, so this is 2. This is, if I look at this one, here and here, just find good points. This is over 1 up 2, so this is also 2, so this is parallel. Parallel. And you can also use this symbol. That's parallel. This is parallel. This is perpendicular. Oops, draw it a little bit better. That means perpendicular. That's shorthand notice. You learn that in geometry, I guess. All right, if we look at this one here, I have it's over 2 up 1. So the slope of, let's call this line 1. Probably help me label my lines. Let's call this line 2. So the slope of line 1 is half. And here, if I come here, it's down to over 1, so this is -2. And if I multiply this, a half times -2 equals -1, and so this is indeed perpendicular. Okay, so that's perpendicular. Now, this one, it almost looks perpendicular, but if we come to find out, the slope of this line is, let's call this one 1, and this one 2, that way we have them labeled. Slope of this is -1, and then the slope of this one is actually over 1 up 3, so it's +3. So if I multiply this together, I get -1 times 3, which is just -3. So this is neither. And so if you get two random lines, the chances of them being neither is, see, I can say this correctly. Mathematically speaking, if I hand you two random lines, the chances of it being neither is 0, right? It literally is 0 chance. Or has measure 0. It's not 0 chance, but has measure 0, which always blows my mind. Because there's so many options which are not, that the chance of you getting it is basically 0. Now, in reality, yeah, a lot of lines are parallel and perpendicular just because we humans like to make things which are straight or not. Okay. All right, so here we'll get into the meat. This is what I definitely will test you on. And so this is review for some, not review for others. So let's just go at it at a good pace. So here, if I give any point, given a line and an equation, I want to find something that's parallel and perpendicular to that goes to the given line. So let's do B first because A is a special case. Let's do B first. So here, the first thing I want to do for this is I want to find its slope because I need to know the slope. So here, let's go ahead and find the slope. In order to do that, we just put it into 4y plus 2x minus 7, and then if I divide out that, I get 2 over 4x minus 7 over. So this gives me the slope of this line was originally a half. For the original line, it's a half. Okay. So if I want to do the parallel version, so the parallel version will also have a half. And then I'm going to go through this point here. So I use this as my point, and I plug it into my point slope. So it'll be y minus y1, which is in this case 1, equals my slope, which is a half, times x minus x1, which is in this case is 2. Crunch through that. Actually, technically, I've done my job. I found an equation of a line. This is the equation of a line. But if we just crunch through it real quick, here I'll have 1/2 x minus 1 plus 1, so we're done. So that's it, right? um, so it's just y equals 1/2 x. So if we want to do the perpendicular version, here we're going to take what we call the opposite reciprocal. So you flip it and change the sign, so m in this case will be minus 2 over 1. So -2, and so we plug in the same point, -1, oops, equals m, which in our case is -2, x minus 2. So here I'll have y is a -2x, so this will become +4, plus a 1, so it'll be +5. Okay. Is everyone really comfortable with this? With finding the parallel and perpendicular of a line going through a point? This is where I'm going to really kind of test and prod your knowledge. I can do another one if you guys need me to, but if this is all a snore fest, I can go on as well. Kind of lost. Okay, so let me do one more. Let me do one more of these. I'll do it on this. Me too. Okay, so let me do at least one more, and we'll go a little bit slowly. Okay. Let me do this one real quick, and then we'll do one more. All right. So here, this is my line. What's the slope of this line? Well, my slope here is 0, right? Because it's a horizontal line. Are we supposed to find parallel? Are we supposed to find both? Yes. So in these questions, I'll ask you to find both. For this type of question. On the exam, I may ask for just one or the other. Depends on which numbers will come out easier, probably. So, all right, so here, the slope here is 0. So if I wanted something that was parallel to this, that went through this line, so the parallel also has slope of 0, right? Oops, sorry. The parallel also has a slope of 0, and it goes through this point. Well, what has slope of 0 and goes through this point? Does anyone know what it is? Okay, I understand it. Yeah, so you find both right now. So when on the homework, I'll show you the homework and we'll find both. Okay. So real quick, guys, what line is parallel to this that goes through this point? Does anyone know? Let's start here. Maybe this is a good place to start. Two, three. Close. You're crunching on it, which is good. So this equation here has a slope of 0, correct? And a parallel line would also have a slope of 0. So what has slopes of 0? Well, horizontal lines. What horizontal line goes through this point? I'm getting nobody. It'd be y equals 2. Oh, someone got it. Yeah, y equals 2. Y equals 2, right? So what's a perpendicular line to something that has slope of 0? Well, it's a horizontal line, right? What horizontal line goes to this point? The horizontal line that goes through this point is x equals 1. And so here for this, that's how we do it. So okay, so let me open up a file, new. Yeah, it's fine. Let me just make another example real quick. Let's just do a simpler example real quick. No, let's keep it complicated. Let's do a simple example. And then let's do a little bit more complicated since we have time. So we'll have 4x plus 2y equals 0. And then we're going to go to the point 1, 1. Okay. All right, so let's find the parallel and perpendicular for these two. All right, so the first thing I want to do when I want to find the parallel and perpendicular for a given line, let me actually go back to the wording real quick. Wording says find an equation of the lines given a point that is parallel and perpendicular to the given line. So this is our given line. So we want to find, so this right here, when I'm breaking down my question, this is the line which I want to make something parallel to it and perpendicular to it. So the only thing I really care about this line is its slope. Because if we went up here, if I drew this the same line, if it wasn't here, say it was like way over here, it's still parallel to it, right? As long as it has the same slope. So the only thing we really care about is its slope. So given this, when you're given this type of problem, let's go back to my thing. Given this type of problem, I want to figure out what's the slope of this line. Well, the slope of the given line for this one is 2. Then if I want to find something that is parallel to it, we'll have the same slope. So just repeat the slope. And I want to go through this point. And so I'm going to use my y minus y1 equals x minus x, x, hold on, m minus x1. So this is how I figure out this. So I know what this is. This is 2. I plug it in here. This is 4. I plug it in here. And this is 0, and I plug it in there. So I'm going to have y minus 4 equals 2. X minus 0. And then I just solve it down. So here I get y equals 2x plus 4. Now for the perpendicular line, I'm going to take this slope, which I found from my given line, and I'm going to do the opposite reciprocal. So opposite reciprocal, okay? And the opposite reciprocal of this would be, so this is technically 2 over 1. So the reciprocal means to flip it, right? So 1 goes on top, 2 goes on the bottom. And then opposite means negate it. So m here would be minus a half. And then given the same point, because we're still using the same point, I just plug it into this formula. And so here would be y minus 4 as before. Instead of m being 2 this time, it's a negative half. And then I get x minus 0. And so here I'll have y equals negative half x plus 4. Okay, so this is the equation for my parallel line. This is my equation for perpendicular line. Is that making more sense? What to do and how to do it? Yes. Okay. Let me do one more for the more complicated one. So this is in standard form, and so grabbing what is the, so this is the given line, right? So this is my given line, and so let me just get to the point where we get what m is. So here we just need to solve it so I have a slope. So we just need to move, I need y clean, and I need to see what's on x. And so in order to do that, we're going to move the x over and the 8 over. So I'll have 2y equals minus 8x plus, or minus 4x plus 8. Divide out the 2, so I get minus 2x plus 4. And so now I know what the slope is. The slope here is minus 2. So the parallel version will have m equals to negative 2. The perpendicular version will be m equals a half, because that's the opposite reciprocal. Here, when we plug it in, it'll be y minus 1 equals x. Same equation here. X minus 1. That's not an x. That is not the x. Give me a eraser. There we go. Here I plug in minus 2. So the m goes here. Remember, m goes here. And then here I'll have y minus 1 equals a positive half over x minus 1. Okay. And technically, if I ask for an equation of a line, you hand me this, you've done your job. You've handed me equations. Okay. So that's how you tackle these problems. You'll see some of those. And let's do the kind of the nastier problem real quick. And so why would I ever use parallel and perpendicular? And so I want to know if these points form a right triangle. In order to do that, I'm actually going to graph them. So here I'll have 3 and 3, which goes here, right? I'll have 8 and 17. Oh boy. 1, 2, 3, 4, 6, 7, 8. Perfect. And then I go up 17. Oh boy. Is this 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. Travel up. And then here's 20. So here's 19. Here's 18. Here's 17. And then 11 and 5. So if this is 8, 9, 10, 11, and then go up 1, 2, 3, 4. All right, so now that I've drawn this, oops, hold on. Why is that not doing what I wanted to do? Oh, perfect. Ta-da. So now that I've drawn this, it helps me figure out which, and let's just call these something. Let's just call this point A, point B, point C, right? So this was A, this is B, this is C. And so if I was going to show this forms a right triangle, how would I go about doing that? Well, here I'm going to look for a right triangle should have a right angle, right? And that means two of these lines need to be parallel to each other. In order to show that these two lines are parallel to each other, we just want to calculate its slope. And so let's do that. So by drawing it, we can easily, technically we could have checked all of them as long as two of them are parallel, but oops, that's not what I wanted. There we go. All right, so let's do this slowly. So we want to find the slope of line AC, or the line segment AC, and then the line segment BC. I want to know what those two slopes are. So we calculate the slope for the first one. So A to C would be 5 minus 3 over 11 minus 3, which gives us 2 over 8. Yeah, that seems right. And that is a fourth. And then B and C. So I'll make, let's just go ahead and make C the top one still. So we'll have 5 minus, in this case, 17 all over 11 minus 8. So 5 and 11, that's 17 and 8. And here I get minus 12 over 3, which gives me -4. And notice since minus 4 times -4 equals -1, that implies, this is mathematical for implies. You'll use this when you write proofs later in life. This implies that AC is perpendicular to BC, line segment BC. So just something you can do with that. Any questions on lines before we move on?